1.5.4. Factoring a perfect square trinomial. A perfect square trinomial is a trinomial that can be written as the square of a binomial. Recall that when a binomial is squared, the result is the square of the first term added to twice the product of the two terms and the square of the last term. A squared plus 2ab plus b squared equals, open parenthesis, a plus b, closed parenthesis, all squared. And a squared minus 2ab plus b squared equals, open parenthesis, a minus b, closed parenthesis, all squared. We can use this equation to factor any perfect square trinomial. A. Perfect square trinomials. A perfect square trinomial can be written as the square of a binomial. A squared plus 2ab plus b squared equals, open parenthesis, a plus b, closed parenthesis, all squared. How to? Given a perfect square trinomial, factor it into the square of a binomial. 1. Confirm that the first and last term are perfect squares. 2. Confirm that the middle term is twice the product of a, b. 3. Write the factored form as, open parenthesis, a plus b, closed parenthesis, all squared. Example 4. Factoring a perfect square trinomial. Factor 25x squared plus 20x plus 4. Solution. Notice that 25x squared and 4 are perfect squares because 25x squared equals, open parenthesis, 5x, closed parenthesis, all squared, and 4 equals 2 squared. Then check to see if the middle term is twice the product of 5x and 2. The middle term is, indeed, twice the product, 2 times, open parenthesis, 5x, closed parenthesis, multiplied by, open parenthesis, 2, closed parenthesis, equals 20x. Therefore, the trinomial is a perfect square trinomial and can be written as, open parenthesis, 5x, plus 2, closed parenthesis, all squared. Try it number 4. Factor 49x squared minus 14x plus 1. 1.5.5. Factoring a difference of squares. A difference of squares is a perfect square subtracted from a perfect square. Recall that a difference of squares can be rewritten as factors containing the same terms but opposite signs because the middle terms cancel each other out when the two factors are multiplied. A squared minus b squared equals, open parenthesis, a plus b, closed parenthesis, multiplied by, open parenthesis, a minus b, closed parenthesis. We can use this equation to factor any differences of squares. A. Differences of squares. A difference of squares can be rewritten as two factors containing the same terms but opposite signs. A squared minus b squared equals, open parenthesis, a plus b, closed parenthesis, multiplied by, open parenthesis, a minus b, closed parenthesis. How to? Given a difference of squares, factor it into binomials. 1. Confirm that the first and last term are perfect squares. 2. Write the factored form as, open parenthesis, a plus b, closed parenthesis, multiplied by, open parenthesis, a minus b, closed parenthesis. Example 5. Factoring a difference of squares. Factor 9x squared minus 25. Solution. Notice that 9x squared and 25 are perfect squares because 9x squared equals, open parenthesis, 3x, closed parenthesis, all squared, and 25 equals 5 squared. The polynomial represents a difference of squares and can be rewritten as, open parenthesis, 3x plus 5, closed parenthesis, multiplied by, open parenthesis, 3x, minus, 5, closed parenthesis. Try it number 5. Factor 81y squared minus 100. Q and A. Is there a formula to factor the sum of squares? No, a sum of squares cannot be factored. 1.5.6. Factoring the sum and difference of cubes. Now, we will look at two new special products, the sum and difference of cubes. Although the sum of squares cannot be factored, the sum of cubes can be factored into a binomial and a trinomial. A cubed plus b cubed equals, open parenthesis, a plus b, closed parenthesis, multiplied by, open parenthesis, a squared, minus, a b plus b squared, closed parenthesis. Similarly, the difference of cubes can be factored into a binomial and a trinomial, but with different signs. A cubed minus b cubed equals, open parenthesis, a minus b, closed parenthesis, multiplied by, open parenthesis, a squared, plus a b plus b squared, closed parenthesis. We can use the acronym SOAP to remember the signs when factoring the sum or difference of cubes. The first letter of each word relates to the signs: same, opposite, always, positive. For example, consider the following example. X cubed minus 2 cubed equals, open parenthesis, x minus 2, closed parenthesis, multiplied by, open parenthesis, x squared, plus 2x, plus 4, closed parenthesis. The sign of the first two is the same as the sign between x cubed minus 2 cubed. The sign of the 2x term is opposite the sign between x cubed minus 2 cubed. And the sign of the last term, 4, is always positive. A sum and difference of cubes. We can factor the sum of two cubes as a cubed plus b cubed equals, open parenthesis, a plus b, closed parenthesis, multiplied by, open parenthesis, a squared minus a b plus b squared, closed parenthesis. We can factor the difference of two cubes as a cubed minus b cubed equals, open parenthesis, a minus b, closed parenthesis, multiplied by, open parenthesis, a squared plus a b plus b squared, closed parenthesis. How to? Given a sum of cubes or difference of cubes, factor it. 1. Confirm that the first and last term are cubes. A cubed plus b cubed, or a cubed minus b cubed. 2. For a sum of cubes, write the factored form as, open parenthesis, a plus b, closed parenthesis, multiplied by, open parenthesis, a squared minus a b plus b squared, closed parenthesis. For a difference of cubes, write the factored form as, open parenthesis, a minus b, closed parenthesis, multiplied by, open parenthesis, a squared plus a b plus b squared, closed parenthesis. Example 6. Factoring a sum of cubes. Factor x cubed plus 512. Solution. Notice that x cubed and 512 are cubes because 8 cubed equals 512. Rewrite the sum of cubes as, open parenthesis, x plus 8, closed parenthesis, multiplied by, open parenthesis, x squared minus 8x plus 64, closed parenthesis. Analysis. After writing the sum of cubes this way, we might think we should check to see if the trinomial portion can be factored further. However, the trinomial portion cannot be factored, so we do not need to check. Try it number 6. Factor the sum of cubes. 216, a cubed plus b cubed. Example 7. Factoring a difference of cubes. Factor 8x cubed minus 125. Solution. Notice that 8x cubed and 125 are cubes because 8x cubed equals, open parenthesis, 2x, closed parenthesis, all cubed, and 125 equals 5 cubed. Write the difference of cubes as open parenthesis, 2x, minus 5, closed parenthesis, multiplied by, open parenthesis, 4x squared, plus 10x, plus 25, closed parenthesis. Analysis. Just as with the sum of cubes, we will not be able to further factor the trinomial portion. Try it number 7. Factor the difference of cubes. 1000, x cubed, minus 1. 1.5.7. Factoring expressions with fractional or negative exponents. Expressions with fractional or negative exponents can be factored by pulling out a GCF. Look for the variable or exponent that is common to each term of the expression and pull out that variable or exponent raised to the lowest power. These expressions follow the same factoring rules as those with integer exponents. For instance, 2x to the power of 1 over 4 plus 5x to the power of 3 over 4 can be factored by pulling out x to the power of 1 over 4 and being rewritten as x to the power of 1 over 4 times, open parenthesis, 2 plus 5x to the power of 1 over 2, closed parenthesis. Example 8. Factoring an expression with fractional or negative exponents. Factor 3x, open parenthesis, x, plus 2, closed parenthesis, to the power of, negative 1, over 3, plus 4, times, open parenthesis, x, plus 2, closed parenthesis, 2, over 3. Solution. Factor out the term with the lowest value of the exponent. In this case, that would be, open parenthesis, x, plus 2, closed parenthesis, to the power of, negative 1, over 3. Open parenthesis, x, plus 2, closed parenthesis, to the power of, negative 1, over 3, multiplied by, open parenthesis, 3x, plus 4, times, open parenthesis, x, plus 2, closed parenthesis, closed parenthesis. Factor out the GCF. Open parenthesis, x, plus 2, closed parenthesis, to the power of, negative 1, over 3, multiplied by, open parenthesis, 3x, plus 4x, plus 8, closed parenthesis. Simplify. Open parenthesis, x, plus 2, closed parenthesis, to the power of, negative 1, over 3, multiplied by, open parenthesis, 7x, plus 8, closed parenthesis. Try it number 8. Factor 2 times, open parenthesis, 5a, minus 1, closed parenthesis, to the power of 3, over 4, plus 7a, open parenthesis, 5a, minus 1, closed parenthesis, to the power of, negative 1, over 4. 1.5.8. Media. Access these online resources for additional instruction and practice with factoring polynomials. Identify GCF. http://openstacks.org/l/findGCF toFact closing parenthesis. Factor trinomials when a equals 1. http://openstacks.org/l/factrinome1 closing parenthesis. Factor trinomials when a is not equal to 1. http://openstacks.org/l/factrinome2 closing parenthesis. Factor sum or difference of cubes. http://openstacks.org/l/sumDiffCube closing parenthesis.